Hello students, this is lesson U3A06b. By the end of the lesson, you should be able to say, I can use medians and altitudes to solve problems. Alright, so let's first define what are these things that we are going to be solving problems with, which is the median and an altitude. Okay, so the altitude of a triangle, actually, you guys do have some experience with it, okay, entering into ninth grade or 10th grade, entering into this high school geometry class, because probably in grade school or maybe even middle school, okay, you guys have found the area of a triangle using the formula 1/2 base times height. And the area of a triangle, yes, the height is considered to be altitude. So it's a line, and so the technical definition goes like this. It's a line drawn from a vertex of a triangle, and it's perpendicularly drawn to the opposite side of the vertex. So what are some ways in which we can draw altitudes of a triangle? So right now I have this obtuse looking like triangle here, and there are different ways in which I can draw an altitude. I can draw an altitude that looks like this. I can also draw an altitude that looks like that, which the altitude is going to end up being outside of the triangle. I can also draw an altitude that looks like that, which again will look like the altitude is going to rest outside of the triangle. So what's the point of me telling you this? I'm telling you this because the altitude doesn't necessarily always have to be inside of the triangle. It could be someplace outside. But the point is that you are drawing a line from a vertex to the opposite base such that it has to form a 90-degree with that opposite base. Now, really important here that I'm telling you this, notice this part right here, that little segment there and this little segment right there. Is that part of the base? It actually is not, okay? It's not part of the segment that makes up the base. However, it is perpendicular to the line that makes up the base, which is important to distinguish. When you're finding the area, when you're finding the area of the triangle, okay, you always use the physical length of the base, which is this guy right here, okay? You don't use the entire length, which is the composition of that length in orange and blue. You only use the actual physical length of the base. All right, so, and again, just to reiterate that the altitude doesn't necessarily always have to rest outside, inside of the triangle, but it can be outside of the triangle. And figure 5 here, okay? This is a right triangle. The actual physical altitude could be a physical side length of the triangle as well, which is what this is saying here. All right. The next feature of a triangle is known as a median. And what exactly is a median? Well, a median is a line drawn from the vertex of a triangle, and that line that you draw from the vertex of the triangle, it has to bisect the opposite side of that vertex. So what are different ways that we can draw the median of a triangle then? Well, if I were to pick this point as the vertex, and I draw a line to the opposite side, bisecting the opposite side, this is the situation I'll end up with in figure 2. That line is the median of the triangle for that particular side, with that particular vertex. We can also have a median that looks like this, and a median that looks like that. So what is the overall takeaway here? The median always, 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 always must rest inside of the triangle. All right. So we're going to find the altitude and area of the triangle. Again, this is just to reemphasize how we find the area or how we justify which side length is the altitude. Pause the video to see if you can figure this out. And welcome back. So right now, okay, if you notice, I gave you 2 segments over here, okay, and they're dashed. So it would be important for us to actually call out what those things are. So let's actually give them some name. Let's call the horizontal component X and call the vertical component H. So which segment is going to be our altitude then? Well, I'm gonna figure out what x is first. So I know that x is equal to 2 plus x is x and 2 will make up the entire segment, which is 3. So x plus 2 will equal to 3. So therefore x must equal to 1. And I also recognize that h there is dependent on what x is. So h being that it's the altitude of that right triangle there, I can use Pythagorean theorem and figure out that h is actually equal to square root of 8 or 2 square root of 2, right? It's all the same. So if I say that this is my altitude and my base then is it going to be 3 or is it going to be 2? Actually, it's going to be 2. 2 is my base. So therefore, I can say area is 1/2 base times height. This is going to be 1/2 of 2 times square root of 8. Or it's really just square root of 8. And square root of 8 may be simplified down to 2 square root of 2. Let's take a look at another example. So in this case here, what we need to do, you're told you have this triangle and that IK is a median. And you're also told that HJ is equal to 3x plus 4, IJ is equal to 2x, JK is equal to x plus 10, and HK is equal to 12. A lot of information. So now you need to find out what are the lengths of HJ, IJ, and JK. Pause the video to see if you can figure this out. So welcome back, ladies and gentlemen. We are going to find out what all of these side lengths are. So how are we going to do that? I know that HJ is equal to 3x plus 4. Let's all label this out, right? If HJ is the entire length, and I know that IJ is equal to 2x, but wait a minute. It also said that IK is the median, right? So if that's the case, then IJ will equal to what portion of HJ? IJ must be half of AJ. I'm sorry, IJ must be half of HJ. Or in other words, HJ is double that of IJ. Either one is the same thing, okay? So with that understanding, okay, I can then perform the necessary substitution to solve. So then I can say, oh, HJ is 3x plus 4 is equal to 2 times 2x. I can then therefore solve for what x is. Subtract both sides by 3x, x will equal to 4. Now that I know what x is equal to, I can then figure out what every piece of information here, or what every side length here is that they're asking for by substituting what x is back in. So hj, therefore, is equal to 16. ij, therefore, must also equal to 16. I'm sorry, ij must equal to 8 because it's half of hj. And finally, jk must equal to 14 because, well, it's just x plus 10. Let's take a look at another example here. I know that AC is the median, so therefore BC will be the same length as CD. So if BC is going to be the same length as CD, I can then easily, well, actually pause the video to see if you can figure this out. So if BC is going to equal to the same length as CD, we can then say BC and CD are going to be equal to one another, or in other words, 2x plus 5 will equal to 7x minus 15. We can solve for x by subtracting 2x and adding 15 to both sides. Or the other way around, we can subtract 5 and subtract 7x from both sides. And we end up with x is equal to 4. By substituting x equal to 4 back into the various equations there, we can then figure out what BC is. BC turns out to be 13. AB is 18. And AD is 28. And lastly, CD must also equal to 13 because CD and BC are the same length. And that's it.